My talk is a microdevice for separation of circulating tumor cells using lateral magnetophoresis and immunomagnetic nanobeads. It's my pleasure to present here today. Outline. The first chapter, I want to introduce my motivation of this experimenter, and second, I will experimenter. Three resultant discussion, and I will show some video demonstrating separation of circulating tumor cells, and chapter 5 will conclude my talks. Motivations. You can see the normally tumor cell in the tissue is attached to the blood vessels. It is interphasion into the systematic circulation, blood or lymphatic vessels, and then it is flow through the vessels in the EMT cells, changed to EMT cell, and it is some part it is extravasation at the site of future metastasis. The cell is go through the tissue area, and then the second metastatic tumor cell. So it is a processor of metastasis. To detect this cell, it is named as a circulating tumor cell. It is first described in the 1960 by microscope, but the number is very small, but it is proportional to the clinical stage. 1 million tumor cells a day is shed into the circulating, but usually in 1 milliliter whole blood, from 1 to 10 CTC cells existed. So it is very difficult to separate these cells. So nowadays, many researchers are focused on the separated and analysis the circulating tumor cells. This data shows that EpCAM is antibody from the circulating tumor cells. This antibody expression is increased. Very different kind of tumors, breast cancer, ovary, colon, and nowadays EpCAM antibody is very important, indicated the count circulating tumor cells. It is a good prognosis, significant of CTCs. The first is breast cancer, the second is prostate cancers, third is colorectal cancers. In case of the MBC, more than 5 cells in the 1 milliliter whole blood, survival rate is increased, but under 5 cells is survival rate is decreased. So, how many cells in the whole blood is give very important information to the prognostic significant. How the drug can be adaptable for the specific persons. So, the count to number of circulating tumor cell in whole blood is very important issues. This slide shows some example now published until now. CellSearch is a very famous company in this field. It is certified of the FDA, only one company in the world. So it is EpCAM antibody bead was utilized for the magnetic separation method. The capture rate, the purity is very low. So in these companies work together, Massachusetts General Hospital (MJC) together, and so they changed to another models to improve the purity and the capturing rate. In Korea, Yonsei University, it is working together with Samsung, and they tried another method, but in this case also need to dilute the whole blood 100 or 1,000 times. So research for the new method, we so introduce some laterally driven magnetophoresis with immunomagnetic nanobead. This slide shows the concepts. The circulating tumor cell has EpCAM antibody on the surface. It is react antigen antibody with the magnetic nanobead. So in this case, it's moving by the external magnet. So, but we increase the impact of the magnetic force. We laid the ferromagnetic wires on the channel surface and put the external magnet on the surface, so it is magnetized as this wire, and the cell with the bonded with the magnetic bead is collected to the in this outlet. Normal blood cell is flowed through this ways. The CTC coated with nanobead is collected in this area, these outlet areas. So it is very simple structure, easy to use, and a low fabrication cost, easy to integrate with the other functional unit. So at first we designed the safety simulators. First we functional distance from the vertically located base permanent magnet like this. So distance between the magnetic force is different. So we can optimize the distance of the two magnets, and with surface press from the height of in the microchannels in the microdevices, as a function of the height of the channels, the magnetic intensity was changed like this. Using the safety simulator, we designed the microchannel and the distance of the permanent magnet. It is a microfabrication procedure. The basically glass substrate and the PDMS substrate is used for the microdevices. For the making the ferromagnetic nano wires, so we use the nickel chrome, cobalt, alloy ferromagnetic material, and electroplatings to the 70 micrometer, and using the CMP process, we control the thickness to 50 micrometer thick, and the PDMS was used the cover substrate, and it to put together two devices, we using U sealing method. It's poly additional between two functional polymer surfaces. It hermetically sealed together. We also fabricated the microfluidic driving setup for the CTC chips. It is chip holders and it's a controlling part, and the microscope will be located in the tops. This shows the microscope and the setup for the measurement. The sample injection here, and the chip is located here. This chip figure shows that this is a pore blood, and between two tubes, the buffer solution tube is located here. Top and the bottom part is the whole blood, and in the middle of two blood streams, and located the buffer solutions. This slide shows the chips sample inlet here, buffer solution, and the lymph node. It's divided into two channel part, and the buffer solution here, and the CTC collected in this outlet. The blood cells are collected in the here two outlets. It shows that this part is it shows the ferromagnetic wires on the bottoms. The CTC cells in the is flowing in this way, and I will show you the demonstration movies. This black material is normal blood cells, and then in the middle of part two port is the CTC cells is flow in this outlet port. This slide shows CTC separation result using the human whole blood before separation, and as it's passing the CTC on the collection outlet part. This slide shows, this movie shows the real time recordings. The CTC is tagging with the fluorescence dyes, so it is flowing here, and the dragging to the lower part, and is going through in the middle of the wires, and this middle outlet part. So we do experimenters as a separation rate as a function of a distance from the magnets. Is 3 millimeter to 6 millimeter. Is 5 millimeter is good for the high separation rate, and we also do experimenter as a function of a distance external magnetic intensity. So as now 190 millitesla is at that case separation rate is over the 90%. This slide shows a real image after separation with the spike, CTC spike, the whole blood samples. This shows WBC is red colors, and this green and red combination is indicate the CTC cells. We also did a real patient, breast cancer patient. It shows we can collect the CTC from the real samples like this. The chip is has a 90% separation rate. I would like to conclude my talks. We designed and fabricated lateral driven magnetophoresis microdevice with immunomagnetic nanobeads and the microfluidic operation system. It shows a recovery rate of 90% and the purity is over 90%. It can be applicable prognostic and predictive diagnostics and companion diagnostic for the new cancer drugs. So I'd like to thank Yeon in the university for the discussion and the comments our device designs. Thank you for your attention.